In this video, we are going to solve an example under parametric equation to broaden our understanding further. So the question is, state the parametric equation of a circle with center in a 2 and 1 and radius 3. B. State the center and radius of the circle given by x minus 4 is equal to 2 cos theta, and then y plus 3 is equal to 2 sin theta. So let's begin. Now, we have established that with parametric equations, the coordinates are given in terms of only one variable. So every point has two coordinates, the x and then the y coordinate. So the x and then the y coordinate. And when it comes to parametric equation, the x coordinate is giving us a plus of r cos theta, where a is the x coordinate of the center, and then r is the position vector. R is the position vector, or r is the line segment, joining the center and then any point on the circumference. Or we can say that r is also the radius. R is the radius. So we have a as the x coordinate of the center of the circle, and r as the radius of the circle. And then also we have y to be equal to b plus of r sine of theta. So these are the parametric equations that we have to deal with. So let's go back to the question. Now we have the center to be -2 and then 1, and the radius is 3. Therefore, the parametric equation is going to be x is equal to, now we know x is equal to a. Now a is always the first coordinate. It's always the first coordinate of the center. And then here the center is given as this, as -2, 1. Therefore a corresponds to -2. So we have -2, and then the radius is also given plus of r the radius is 3 plus of 3 cos of theta. So that's the parametric equation. And then also we have the parametric equation on the y-axis to also be equal to 1. Let me put on, though we don't, 1 plus, that's b. So here b corresponds to 1, and then the radius is also 3 sine of theta. So that's very simple. It is an objective question, but sometimes as part of the subsections or the sub questions under a main question on an exam, they can introduce this as well. So take note. And then the next question is state the center and then the radius. So here we were told to state the parametric equation of the circle, but then they are also telling us to state the center and radius of the circle when the parametric equation is given. So here the parametric equation is given, so it becomes very simple. We can clearly determine the center and then the radius. So on the x-axis, so here we have our x minus 4 is equal to 2 cos of theta. Just rearrange it. So x is equal to 4 plus 2 cos of theta. Therefore, our a is equal to 4, and then also our r is equal to 2. And we have another one also. We have our y, and then the next one is y plus 3 is equal to 2 sine of theta. So you realize that the radius is still the same. It's constant. So it's the y, and then is the y or the a and then the b that changes. So we have this one to be equal to y is equal to -3 plus of 2 sine theta plus of 2 sine theta. So here we can therefore determine our b. We can therefore determine our b. Our b is equal to b is equal to b is equal to -3, and then our r is also equal to 2 for the same, because it's the same circle, so the r will not change. Radius is constant. Radius is just the locus. You can say it's a locus, yeah. So it's constant, so it doesn't change. So here we can, since we know a and b and then r, we can state the center and then the radius of the circle. Therefore, the center of the circle C is equal to 4, -3, and then the radius of the circle is also equal to 2. So this is how you can basically solve the questions of this type. Thank you very much, and let's meet in the next video. Bye.